morning, students. New chapter, chapter number 8, electromagnetic waves. Why it is termed electromagnetic waves? Okay, that we will see in this chapter. Yes, this word I think you have heard from the beginning of physics, that is from 11. Okay, what is electromagnetic wave? Okay, so yes, in this chapter you are able to understand what actually is electromagnetic waves and why these two words we have to write together or we have to understand together. That is electromagnetic waves. Okay. Yes. First of all, it is introduction. Okay. And yes, it is theoretical. So I have to write on board. And yes, I will now relate or I will explain it. Okay. So yes, what is electromagnetic waves? What is introduction? See, if you remember chapter 4, moving charges and magnetism. After Ørsted's experiment, we have one conclusion that moving charges means electric current produces magnetic field. Yes or no? Yes, it is. Okay. Then in chapter number 6, we have proved K due to changing magnetic field, and due to that, yes, flux is changed, electric field is produced. Again, due to time varying magnetic field, due to time varying magnetic field, electric field is produced. So now question is the converse possible? Due to time varying electric field, can magnetic field will be produced? Yes or no? That we have to see. Okay, see here it is. Electric current produces magnetic field and two current carrying wires exert a magnetic force on each other. Yes, we know. Okay, if two wires are placed parallel to each other, currents they are flowing in same direction, then they will attract each other. While current is moving in opposite direction, then yes, they will repel each other. So yes, we know this statement. Okay, electric current produces magnetic field and two current carrying wires exert a magnetic force on each other. Also, magnetic field changing with time gives rise to an electric field. Chapter number 6, electromagnetic induction. Then yes, question is the converse true? Does an electric field changing with time give rise to a magnetic field? Yes, it is one question. And yes, we have its answer that James Clerk Maxwell argued that this was indeed the case. Okay, not only an electric current, but also time varying electric field. Time varying electric field generates magnetic field. Yes, Maxwell suggested. Okay, he argued that yes, it is possible. It is possible. Okay, while applying Ampere circuital law, what is Ampere circuital law? If you remember, Ampere circuital law is yes, it is integration B dot dl is equal to mu 0 sigma I, where it is called line integration of magnetic field over a closed loop. Line integration of magnetic field over a closed loop is equal to product of mu 0 and sigma n is total current enclosed by any closed loop. Total current enclosed by any closed loop. So yes, Maxwell applied Ampere circuital law to find this equation's consistency at different points. Okay, while applying the Ampere circuital law to find magnetic field at a point outside a capacitor connected to time varying current, Maxwell noticed an inconsistency in the Ampere circuital law. Inconsistency, yes, he noticed one inconsistency in Ampere circuital law. Means yes, there is some missing term. Okay, right hand side we cannot write only mu 0 sigma I. Right hand side we cannot write only mu 0 sigma I. And he also suggested that the existence of additional current, the displacement current. Yes, he suggested not only his current which is flowing from battery from outer circuit is not only cause. Okay, yes. He suggested that existence of additional current which is called displacement current, and after that he formulated some equations with the help of its electric and magnetic fields, their sources, charge densities, etc., and such equations are called Maxwell's equation for electromagnetism. Clear about this? So it is history that yes, you have to remember this flow, okay, from the beginning, from chapter number 4, then chapter number 6, now it is in chapter number 8. So yes, what is question? Does an electric field changing with time give rise to magnetic field? Maxwell suggested yes, and that missing term in Ampere's electrical law was termed as displacement current. So now we will see what is displacement current actually, okay. So yes, Maxwell suggested that there is one missing term in Ampere's electrical law after his experiments. Also, the most important prediction emerged from Maxwell's equation is the existence of electromagnetic waves, which are time-varying electric and magnetic fields that propagates in space. And yes, with the help of such equations, okay, speed of waves according to equations turn out to be 3 × 10⁻⁷ meters per second, that is speed of light. So yes, this led to the remarkable conclusion that light is an electromagnetic wave. Yes, light is an electromagnetic wave. So yes, Maxwell argued that time varying electric field produces magnetic field. Okay, he suggested additional current called displacement current. He formulated some equations. From such equations, what was prediction? Yes, existence of electromagnetic waves, and their speed is termed to be 3 × 10⁻⁷ meters per second, that is speed of light. And it is one most important statement that light is an electromagnetic wave. Light is an electromagnetic wave. Because in chapter of dual nature, that is radiation and matter, you have to understand this concept. Okay, yes, here we have to see that. Okay, yes, after this all theories, after this all experiments, after this all equations, what is conclusion? Light is an electromagnetic wave. So yes, this point you have to remember. So yes, it is all about introduction. Now we will see first theory of this chapter, which is displacement current. What is displacement current? See, in Ampere's electrical law, according to Maxwell's equation, integration B dot here is equal to mu 0 I plus question mark means missing term. And Maxwell suggested that this missing term is nothing but displacement current. Okay, so now what is displacement current? That we have to see. See, it is one parallel plate capacitor. It is connected with battery. Okay, yes, from this battery, this capacitor gets charged. Between two plates of capacitor, there is a medium, for example. Okay, so yes, current I enters the positive plate and leaves the negative plate of a parallel plate capacitor. If the capacitor plates are very close to each other, then field between the plates A is equal to sigma upon epsilon 0, or is equal to it is Q upon A epsilon 0, because we know that sigma is equal to it is Q upon A. Now, when capacitor gets charged, to see, charge on plates of capacitor increases. Means charges on plate of capacitor is not fixed. It is time varying. It is time varying. As time passes, charge increases. As time passes, charge increases. As time passes, charge increases. Yes or no? Yes, it is. Okay. So yes, when capacitor is getting charged between the plates, we can say as electric field E is equal to Q upon A epsilon 0. Epsilon 0, that is permeability of free space, constant. A, that is area of plate, constant. So yes, E depends on Q. E depends on Q. Okay, capacitor gets charged, means charge changes, so obviously electric field also changes. So see, del E upon del T is equal to 1 upon epsilon 0 A constant, dq upon dt, and this dq upon dt is called ID. Where what is ID? ID is equal to epsilon 0 A del E upon del T. Now see, A del E, electric field into area, it is nothing but flux. It is nothing but flux. So see, ID is equal to epsilon 0 A del E upon del T is equal to epsilon 0 del phi upon del T, which is called displacement current. It is called displacement current. And yes, we can also write this in form of integration. That is, ID is equal to epsilon 0 integration del E upon del T dot D. Clear about this? Okay, so yes, now how to write Maxwell equation? Sorry, Ampere circuit law. Integration B dot dl is equal to mu 0 I plus here it is, see, mu 0 I. Now this I is replaced by IC. Why we have to write IC? I will explain. Okay, IC plus mu 0 ID plus mu 0 ID. So mu 0 common, it is integration B dot dl is equal to, it is mu 0, it is mu 0 IC plus ID. And this equation is known as Ampere Maxwell Law, which shows that total current, see this total current, okay, enclosed by that surface, which is this parameter, okay. So yes, this total current is summation of conduction current which flows outside capacitor and displacement current which flows between plates of capacitor. Yes, it is IC which is flowing conduction current which is flowing outside, and ID, that is displacement current, which is flowing inside. Clear about this? So yes, this equation you have to remember, integration B dot dl is equal to mu 0 IC plus ID, where ID is called displacement current, Clear about this? So yes, it is about what is displacement current and what is Ampere's Maxwell's law. Clear about this? Yes, you have to again remember that total current is addition of conduction current and displacement current. Conduction current outside, displacement current between the plates of capacitor. Clear about this? This is it for today. Yes, we have obtained equation of Ampere's Maxwell's equation. Yes. Now, what is reason? Okay, what is experiment of Maxwell? Okay, how he suggested, how he argued that yes, due to varying electric field, magnetic field is produced. Okay, so yes, we will see his experiment and again its conclusion. See, what is experiment? Again, displacement current is according to new textbook, and yes, what is reason? How he make relation? See, let us consider the process of charging of capacitor and applying Ampere circuit law. Integration B dot dl is equal to mu 0 sigma I, or we can say it is I. Okay, see here it is parallel plate capacitor between two plates. It is as medium current flowing is it is IT. Okay, yes, I am taking one point P here outside plates of capacitor at distance r. So we know that it is one current carrying wire. So due to this current carrying wire, magnetic field is produced. So at point P we have some magnetic field. At point P we have some magnetic field. At point P we have some magnetic field. And yes, how to find that magnetic field? I have presumed 1 ampere loop of radius r. As it is circular, at each and every point magnitude of magnetic field is same and direction it is in tangential direction. Yes, you know it. Okay. So yes, at each and every point on this Ampere loop having radius r, magnetic field, its magnitude is same, direction it is in direction of tangent. Okay. If I apply Ampere circuit law, that is integration B dot dl is equal to mu 0 sigma d, integration B dl, it is 2 pi r, mu 0. What is total current enclosed by this? What is total current enclosed by this loop? Yes, it is IT. Yes, it is IT. Okay, so yes, here it is IT. So yes, this is how we can find magnetic field at point P. So conclusion of this first figure A is at point P we have some magnetic field. At point P we have some magnetic field. Now, as shown in figure B and C, suppose surface we have changed. Okay, this surface it is like a pot. Okay, it is point P again at distance r. And it is one surface like this, and such that this surface, this other end lies between two plates of capacitor. Similarly, it is like different box, okay, upside, downside, okay, and this side it is between two plates of capacitor. Clear? So now, if we apply Ampere circuit law in these two figures for these two surfaces, then yes, integration b dot dl, as we have to find at point P, distance is r, so obviously P is equal to, it is mu 0 to pi r, left hand side is same, but right hand side what happens, see, is there any current? Is there any current? No, no current. So yes, right hand side will be 0. Is there any current between two plates of capacitor? No. So yes, current will be 0. So right hand side will become 0. See, on applying Ampere circuit law to such surfaces with the same parameter, we find that left hand side of equation has not changed, but right hand side equation is 0 as no current passes to the surface B and C. So we have one contradiction. What is contradiction? Yes, what is contradiction? If, see, this right hand side becomes 0, then right hand side becomes 0 means at point P, what is magnetic field? 0. Yes, obviously, right hand side becomes 0. Then B 2 pi r is equal to 0 means B is also 0. B is also 0. So what contradiction we have? We have a contradiction that with the help of figure A, if we have calculated magnetic field at point P, yes, magnetic field exists. Okay. There is magnetic field at point P. Calculated one way, there is magnetic field at point P according to figure A. But calculated another way, the magnetic field at point P is 0 at the same point. According to first figure, that is magnetic field. But according to second and third figure, magnetic field is 0. So yes, it is contradiction. Yes, it is contradiction. So yes, in this Ampere circuit law, there is something missing. There is something missing, and that missing term was named displacement current by Maxwell. The missing term was named by displacement current by Maxwell. And yes, the missing term must be such that one gets the same magnetic field at point P, whatever surface we use, whatever surface we use. Okay, we can say one equation, general equation. If we put any values in that equation, we will get the same result. Okay, so yes, is there anything between two plates of capacitor? What is question? Is there anything between two plates of capacitor? So yes, electric field is between two plates of capacitor. And as it is charging process of capacitors, charging means charge on plates of capacitor changes. So obviously electric field between them changes. And yes, we have obtained equations. To obtain equations, E upon dt is equal to 1 upon epsilon 0 a dt upon dt. Then I is equal to, it is, yes, it is here, it is epsilon 0 d phi upon d. Or you can say it is a d. Okay, and this missing term is called displacement current, which is due to changing time varying electric field. So yes, what is Maxwell's correction? Integration b dot dl is equal to mu 0 IC plus ID, where IC is the current carried by conductors due to flow of charge. It is called conduction current, which actually flows outside. While the current due to changing electric field is called displacement current, which is actually between two plates of capacitor. So now what happens? See, now if I use this equation, that is integration b dot dl is equal to mu 0 IC plus ID. When I am talking about the point outside plates of capacitor, then obviously outside, then yes, outside, here I will write outside plates of capacitor, IC is not 0, but ID displacement current is 0. So yes, there is IC. So we will get some magnetic field. But between two plates of capacitor, yes, IC is equal to 0, but ID is not equal to 0. There is displacement current. So yes, between two plates of capacitor, magnetic field is due to displacement current, that is varying electric field. So now if I place mu 0 IC plus ID, and now if I apply this law to this any circuit, we will get some magnetic field at point P in each case. Clear about this? So yes, it is Maxwell's correction in Ampere's law, and now it is called Ampere Maxwell Law. That is integration b dot dl is equal to mu 0 IC plus ID. Clear about this? So yes, it is all about displacement current. In next lecture, we will see the another conclusions from Maxwell's law. Okay.